Hi girls, so we are going to be talking today about something called the discriminant, and this is going to help us in our further investigation of the quadratic formula. So I'm going to start off with a definition and give you some further explanation of why we would use something like this, and then go through a couple of examples. So let's get started with a simple definition. The discriminant is something that can help to determine the number and type of solutions to a quadratic equation. And the discriminant can be defined simply as what is found under the square root. So I'm just going to set it equal to d. And what we find under the square root of the quadratic formula, if you remember from the song, is b squared minus 4ac. So you're going to be substituting values into this formula for the discriminant, and then based on the number that you get is going to tell us a little bit more about our solution. So I made a chart down here that can kind of simplify this for us. So this is called the nature of the roots of a quadratic equation. So when you have an equation in the form ax squared plus bx plus c equal to 0, and you find the discriminant, which is shown here, if you get an answer that is positive or greater than 0, we know that you are going to have two solutions, and those two solutions are going to be real numbers or real solutions. If you have the discriminant and it ends up being equal to 0, we know that you are going to have one distinct real solution. And then finally, if you end up with an answer that is negative, thinking about this, so the number is negative under the radical, that means that you're still going to have two solutions, but it's going to be a complex or imaginary solution. So we'll just say complex. And one thing to note for the middle column here, technically you get two solutions, but you only list one because it ends up being a double root. So I'm just going to put like a little star down here that would be a double root solution. So what I'm going to do is have you go through 3 different examples evaluating the discriminant to figure out the type of roots or type of answers that we get. So again, the instructions say, and be careful when you read these instructions, we're not solving. So we're without solving, we're going to determine the nature of the roots. So in this example, we have our equation written here, but we need to make sure it's in the form of ax squared plus bx plus c equals 0. So that means that we need to take care of this -7 and make sure we move that to the left-hand side. So we can rewrite this as x squared minus 6x plus 7 equals 0. And then what we're going to do is just use the discriminant to figure out what kind of solutions we're going to have. So we're going to set this equal to d is equal to b squared minus 4ac. So let's go ahead and plug in our values for a, b, and c. So b is -6 squared minus 4 times 1 times 7. And then just go ahead and evaluate that or simplify. So we get 36 minus 28, which gives us an answer of 8. So I go back to my chart and I look and I have a value that is greater than 0. So that means it's going to be, I'm going to have two solutions and they're going to be real numbers. So I'm going to say my solution, I'm going to have two real solutions. All right, so let's take a look at example B. So I'm just going to draw a line here so that we don't go into the other problem. So again, we're set up with an equation here, but we notice that the -9 is on the right-hand side, so we need to move that to the left. So let's rewrite this as x squared minus 6x plus 9 equals 0. And let's go ahead and evaluate the discriminant. So d is equal to b squared minus 4ac. I'm going to plug in my values, so that's going to give me again negative 6 squared minus 4 times 1 times 9. I'm going to go ahead and evaluate that, so I get 36 minus 36, and I get an answer of 0. So if I go back up to my chart, I look that it's equal to 0, so that means I'm only going to have one real solution. And that means that I also have a double root, so you could also write dr for double root. All right, so go ahead and pause the video and work on that last one and see what you come up with. Okay, so the last example, we're going to again write this in the correct form, so that's going to be x squared minus 6x plus 11 equals 0. We're going to evaluate the discriminant, so that's d equals b squared minus 4ac. I'm going to substitute my values in, so again that's negative 6 squared minus 4 times 1 times 11. So I end up with 36 minus 44, which gives me an answer of negative 8. So if I look at my table, that's going to give me two complex solutions. So two complex solutions as my answer there. All right. One other thing, just in case you just see the wording different, you might see that it's non-real. So I'll just include that for your notes. Some books use different notation, so I just want to make sure that you see that if you get a complex solution, that also means it's a non-real number, again, because it's an imaginary number that you guys know about from studying from our last chapter. All right, so tonight's homework, or today's homework, is going to be to evaluate different equations without solving and determining the nature of the roots. And then there is some practice on solving and using any of the three methods that you think is easiest. So again, just to review, that would be solving by factoring, solving by completing the square, or solving by using the quadratic formula. All right, so just be sure to pop on to Google Meet if you guys have any questions about this, and I will talk to you soon. Thanks. Bye.